represent stuff in the past, you would say -1, -2, etc. Except that this means the last year. So this is December 31st all the way up to January 1st of the previous year and so on. So that's the way you should think about it. And then discount rate, which we represent by the symbol R, is the percentage symbol, right? And cash flows, positive numbers to you is a plus, and the negative numbers is a minus. Right? So this is the convention. So this is what you should do. First thing. So anytime when you solve any problem, that we are doing, it doesn't matter whether problem set 1 or throughout the course. The first step is you want to condense all the information into a timeline. That's the first step in any problem. Okay. Once you do that, then things become much simpler, because then you can figure out. Because half the difficulty is figuring out on how to put it on the timeline. Okay. So that's the most important skill that you need. What was the other thing? Yeah. So for solving all these problems, the only thing that you need is all these formulas. You don't need anything else, including the the special cases which require formulas. They are also the growing annuity and the growing perpetuity are also programmed, right? So you don't have to remember any formula. For all your calculations you can use any of those. Okay. So that's the first step. The second thing is, make sure when you're solving for something like, let me see what I can think about. When you're solving for interest rates, you have to give one positive number and one negative number. Otherwise Excel will not be able to solve. Right? Because I told you that Excel always thinks about inflows and outflows to balance out everything. Right? In the interest rate, so you have a future value and you have a present value and a payment. So if you give present value as negative, remember to give future value as positive, etc. Otherwise you can't get a solution. Okay? So that's the important thing about finding interest rate. All the other stuff should be okay, I think. And forget about the sign that Excel tells you, because that doesn't mean anything. Right? You have to figure out the correct sign according to your. Okay, so these are the things that you should know about time. Any questions on these? So the first thing is to say that the present value of $1 tomorrow is, you have to discount it back to today. Future value of $1 is, you have to compound it to tomorrow. And the functions that you would use are present value functions in Excel or future value functions in Excel. Okay? So if it's a single cash flow, you would set the payment to be 0. And the future value is a single cash flow. But if it is a series of cash flows, you would set the future value is 0, but you put it as payment. So this is the important thing that you need to. So you can handle all those types of cash flows by ensuring that you take care of whether it's a single cash flow or if it's a multiple cash flow. Okay. For example, let's say 0 time period 10, this is 7%, and let's say it's $1,200. So this is a single cash flow. Same 7%, except that it is $125 every pay. So what's the present value in both of these cases? So one thing that you should know is, in any of these time value of money problems, the focus is to figure out 4 things so that you can figure out the unknown, which is the fact. There is nothing more, however complicated the problem is, it will always be 5 things. You figure out 4 so that you can back out the first. Okay. So once you know what is it that you need to back out, use the appropriate formula. So that's all there is to it as far as any time value of money problem. What is difficult is, you will have 3 or 4 of these combined and stitched together. So you have to unpack each one separately and then do it, and that is what creates the difficulty in any problem in this section of the course. Okay. So as long as you can keep each piece separately, you should be able to figure out what the cash flows are. So for example, let's take this one. So you have to find present value. So T is 10, interest rate is 7%. Again, when you use Excel, don't forget the percentage sign. If you give 7, Excel interprets it as 700%. Right? So it's 7% or 0.07. So there's no payment, so you have to give 0. And then the future value is 1200. So you get 610 point. Okay. So this is how you would do a single cash flow. Forget about the sign, because Excel, if you give a positive number, it will give a negative number as an answer. If you give a negative number, it will give a positive and vice versa. So forget about the sign. Now how would you change that for the second problem? You would say that the future value is a 0, but then give a payment as 125. So then Excel immediately understands that that 125 has to get repeated 10 times. That's the meaning of the PMT. Because it will then repeat that as many number of times as you say as a period. So the present value in this case is 877. Okay. It's oppressive, isn't it? I can hear your sigh. So the next thing that you need to know is what is known as the additivity principle. Okay, what this means is you can add or subtract cash flows and then figure out present values. Alternatively, you can figure out present values first and then add or subtract. It doesn't make any difference. That's what additivity principle says. The order of operation, whether you first add cash flows or subtract cash flows and then find present value. Alternatively, you figure out present values first and then add or subtract. It doesn't make a difference. The answer is going to be obvious. So let me give you an example. Let's say the present value is some number, okay? So let's call it as X. I'm just making up the answer, okay? This is simply nothing but an annuity, okay? So the present value of this annuity at R% is X dollar. Now we have one more annuity. Okay, so these are the two cash flows. The question I'm asking is, what is the present value of $1 at t equal to 5? So how will you think about this problem? So the first cash flow is 5-year annuity. The second one is the 4-year annuity. The question is, what is the present value of $1 at time t equal to 5? We just talked about the addition principle. So how would you apply addition principle in order to figure out the answer? So so what is the first step in any time value of money problem? Create a timeline and figure out what's going on, right? So the first thing that you would do is present value of $1 at t equal to 5. So 0, 1, 2, 5, $1 R%. So this is what you have to figure out. Okay? So how will you get this pattern?
Are we adding these two together?
You can do whatever you want with those patterns. So we just talked about the additivity principle. So what we want is a pattern like that, right? That is what is the present value of a single dollar.
Yeah.
The question is, how do you get that from what we have?
Minus y from x.
Okay, minus the y from x, subtract y from x. That's what he says. Suppose I do this, x minus y, which is the same as subtracting the patterns, correct? What will you get?
C at 5.
you will get one cash flow of C dollars at 5. Right? And so the value of that should be
C over 1 plus R to the 5th.
no, not that way. So the left hand side, the present value,
Y minus X.
y minus x or x minus y. So when you said that it is x minus y, what principle did you use? Additivity, right? What does the additivity principle says? You can add and subtract cash flows. Whatever is the present value of the resultant answer is the same as adding and subtracting the present values itself. That's what additivity principle says, right? It doesn't matter whether you add or subtract the patterns to get any complicated cash flow. The answer that you get as the cash flow pattern, the present value of it is simply the addition or subtraction of the corresponding individual present values. Right?
So long as they're at the same period, correct?
So long as they have the same discount rate. It need not be the same period, right? Because here it is 5, here it is 4, but still I can add and subtract.
But you're still subtracting the 4C from the 4C on the other thing, right?
Yes, as long as they are at the same point in time
Okay.
and they have the same discount rate, which is the most important thing, then you can add and subtract cash flows. Suppose if the discount rates are not the same, then you have to make an adjustment. So, but we are not talking about that. So for this to work, the discount rates must be the same.
So in this case, we're finding the opportunity cost.
Yeah, another name for this R is opportunity cost. But what I'm saying is, this pattern, so you can add and subtract patterns to get any pattern you want. The present value of the pattern that you get is the same as the present value of the overall answer. In other words, I first find the answer and add and subtract, or I subtract first and then try to find the answer. It doesn't make any difference. The result will always be the same. That's the key idea behind additivity principle. So once you understand this, then all you're doing is pattern recognition. Right? So if you subtract these two, you get this. So this is the answer. So then how do I figure out what is the present value of a single dollar? So this is the present value for C dollars. So the present value for a single dollar would be?
C over 1 plus R to the 5th.
No. In terms of what we already know.
Why would we do that?
Divided by C. Suppose if I gave you this question, I'm just making up a number. Suppose C was 10. Okay? And this X was, let's say, 70. I'm just making up numbers. And let's say this was 62. Okay? I'm just making up this number. So the question is, what is the present value of a single dollar in that case? 70 minus 62, which would be equal to $8 is the present value for a cash flow which is $10. So if the present value is $8, if the single cash flow is $10, what is the present value if it is a single dollar? 8 divided by 10. Remember Ajima? Proportion, right? Because cash flows are scalable, right? The present value for $1, you just scale it up by C dollars, that will give the present value for C dollars. So that's the way it works. So the thing that you needed to know to solve this problem is that by subtracting this pattern from this pattern, you get a single cash flow. Now the question is, what is the value of that single cash flow? I can subtract and add the present values directly, that way I will get the answer. And then I figure out. So suppose if this problem was given with no information about R, you can still solve this problem, right? Do you see what I'm saying? So supposing I told you that the individual cash flows are $10, but the present value for the first case is 70 and the second is 62, you can solve the problem. You don't need to know R, because you can apply the concept. So this is an application of the additivity principle. In other words, every time when you are having to solve problems of this kind, you are always looking for patterns. What pattern, if I combine, will give me the pattern that I am looking for? So you can combine patterns as by only two ways: add them or subtract them. Right? These are the only two options. So there is very limited things that you can manipulate. You see what I am saying? If you understand that these are the only things I can do, then systematically you can eliminate and figure out what is what.